All right, today we're talking about ratio segments. And we're going to start with triangle ABC, and I'm going to draw a second line through the triangle that intersects two sides of my triangle. And then I'm going to add these little black arrows. The black arrows mean that these two lines are parallel. So anytime you see two little arrows in the same direction, that means that those two lines are parallel. So not only does this line intersect two sides of my triangle, it's parallel with a third side. And we're going to call the points where the new line intersects the triangle points D and E. This is still triangle ABC, but I have new points D and E. That line is actually going to help us create a brand new triangle, right? So now we have two triangles. I have triangle BDE and I have triangle ABC, or I could call it BAC or CAB, right? All kinds of different names. It also creates a set of parallel lines and a transversal. So make sure that you know about parallel lines and transversals before you continue. Since DE and AC are parallel, that means that BA or AB is a transversal, right? A transversal intersects two parallel lines. Well, let's take a look at what that does for our angles. That makes angle BDE, this little angle in here, and BAC, the angle down here, corresponding angles. And as we know, corresponding angles are congruent if the lines are parallel. There's also a second transversal that's created by doing this to my triangle. BC is also a transversal because it's yet another line that intersects with my two parallel lines. Well, that also creates a set of corresponding angles, BED and BCA. And as we know, corresponding angles are congruent. It also happens that there's something called a reflexive property where I can say an angle is congruent to itself. So I'm going to say that angle B is congruent to itself by the reflexive property. Well, since we have at least two angles that are congruent, I can say that those two triangles are similar by the angle similarity theorem. So I'm going to say that triangle BDE is similar to triangle BAC. Now we're going to take a look at some of the proportional sides for our similar triangles. So for my two triangles, I can say that BA and BD are corresponding sides, so BA over BD, large over small, and BC and BE are corresponding sides, so BC over BE creates that same proportion, right? Same scale factor, large over small. And also AC and DE are corresponding sides. So large over small, I put AC over DE, and that should share the same scale factor. So all three fractions should be exactly the same, right? They should all three have the same scale factor. We're going to focus though just on those first two. So I'm going to bring those first two down, BA over BD and BC over BE, and of course that creates a proportion. But now we're going to do a little bit of manipulation. So hang on for just a second. Don't write anything in your notes right now. Just focus and follow along. I'm going to take this side, BA, and I'm going to say that if I added the two smaller portions of that line together, it would equal the whole length. So I can say BD, the length from B to D, when added to DA, the length from D to A, gives me the whole length BA. So one more time, BD when added to DA equals the whole line segment from B to A. Now this actually has a special name to it. It's called the segment addition postulate. It means that I can take two smaller segments and add them together to get a bigger segment. I'm going to do the same thing to the other side. I'm going to take BC and I'm going to break it down and use the segment addition postulate to add the two smaller portions together to equal the longer segment. So I'm going to say BE when added to EC equals the whole segment BC. And again, that's called the segment addition postulate. Two smaller segments added together form a larger, longer segment. Now I'm going to do a little bit of replacing. I'm going to replace BA with what it's equal to. And I'm going to replace BC with what it's equal to. If I do that and I substitute into my proportion, it looks like this. BA can be replaced by BD plus DA, right? Because they're equal to each other. BC can be replaced with BE plus EC using my segment addition postulate, and simply substituting gives me a new look to my proportion. But now I'm going to take this even one step further. I'm going to split these terms in my numerator so that they have their own denominator, that each one has their own denominator. So take our original proportion, BD over BD, DA over BD, BE over BE, and EC over BE. All I'm doing is taking the terms in the numerator and splitting them so that they each have their own denominator. And of course, BD over BD is equal to 1, right? Any number over itself is 1. So is BE over BE. Anything over itself is 1. Now, what happens if I were to subtract 1 from both sides? I would be left with DA over BD equals EC over BE. Now I'm going to take whatever I'm left with and we're going to go back and take a look at our original triangle again. This is what I ended up with, right, when I simplified my proportion. And take a look at where those segments are. DA over BD is equal to EC over BE. These are called ratio segments, and they are proportional as long as these two lines are parallel. Now this is the part that needs to go in your notes. Please make sure to draw this diagram and our proportion. Pause the video if you need longer to write that down. So I'm going to say that if these two triangles are similar, then this proportion is true. DA over BD is equal to EC over BE. There's actually several ways I can set up that proportion, of course. There's actually 8 different ways, but this is just one of them. And the official definition, or what needs to go in your notes, is the intersecting line splits the sides into proportional parts. To put it a little more formally, the triangle proportionality theorem is what this is called. And it says if a line parallel to one side of a triangle intersects the other two sides of a triangle, then the parallel line divides these two sides proportionally. That's our official definition. Pause the video again if you need to write this down. It should go in your notes for sure. Let's take a look at some examples and see what happens with that triangle proportionality. Let's say that I need to find x, and I have the lengths of 3 out of those 4 segments that we were talking about just a minute ago. According to the diagram, because of these two triangles, it's telling me that AC and DE are parallel. That's the key to saying that these are similar triangles and that the triangle proportionality can hold true. And that's what's going to allow us to create the proportion. So I'm going to say DA over BD, 2 over 5.5, is equal to 3 over X, EC over BE. And then it becomes a simple matter of doing some cross products. When I do cross products, I get 2x equals 16.5, and when I divide by 2, I find that x is equal to 8.25. Quick side note, make sure to pay strict attention to directions. If the problem simply asks you to find x, then you're done. You would write x equals 8.25. But if the problem asks you to find the missing length or the length of BE, you would need to write your answer as BE equals 8.25 units. Make sure that you know and have in your notes the difference between the two instructions versus how the two answers should look. Let's take a look at another one. This instruction says to find the length of segment CA. So we're going all the way from C to A. Now we don't know how to find the whole segment at once, but I can use a proportion to find AD, right? I can use my triangle proportionality theorem. I'm going to name my unknown segment X. And I'm going to set this up so that 6 over 9, or I could put 9 over 6. If I put 6 over 9, though, I need to put 5 over x. I could go the other way and say 9 over 6 equals x over 5, and that's absolutely correct as well. When I do cross products, I get 6x equals 45, and when I divide by 6, I find that x is 7.5. Now I go back to the instructions. Did it ask me to simply find x? No, it asked me to find the length of CA. So now that I know that AD is 7.5, to find the whole length from A to C, I have to add 7.5 to 5. Be careful to answer the right question. 7.5 plus 5 is equal to 12.5, so I need to say that CA is equal to 12.5 units. Remember, with the line over the top, that's the name of the segment CA. Without the line over the top, that means the length of segment CA. The length of CA is 12.5 units. Here's a super important note. The triangle proportionality theorem also works in reverse. I can actually show that two lines are parallel by showing that the triangle sides have been divided proportionally. So I can use that triangle proportionality theorem to show or prove that two lines are parallel. Let's take a look. If I need to show or prove that DE is parallel to AC, look at the picture, DE and AC, we need to show that they're parallel. I can use my triangle proportionality. So I can set this up in my proportion 9 over 3 equals 10.5 over 3.5. And when I do cross products, I need to show that both diagonals are the same. When I do cross products, I get 31.5 equals 31.5, which of course is true. And if that's true, I can say that DE and AC are definitely parallel. If those two cross products gave me different numbers, I could also prove that the two lines were not parallel. We're not quite done yet. There is one more little piece to this section. There's another type of line inside of a triangle that creates proportional segments. We're going to start by taking a look at angle B. I'm going to actually take a line and split angle B into two equal halves. When I cut that angle in half, this red line becomes what we call an angle bisector, since it actually bisects the angle. Bisect means cut into two equal portions. The angle bisector, believe it or not, actually splits this opposite side into two segments that are proportional to the other sides of the triangle. Let's take a look at what that proportion is. This is actually called the triangle angle bisector theorem, by the way. That needs to go in your notes. You'll want to pause the video for just a second so you can make sure that's written down. Here it is again in case you missed it. Alright, so what does all of that high-tech mumbo-jumbo mean? It means that because angle ABD, right, this half of my angle, is congruent to angle DBC, this half of my angle, then AD over DC is equal to BA over BC. This actually creates proportional segments. AD and DC are corresponding parts, and AB and BC are corresponding parts, and I can set that up into a proportion. Please make sure that this picture and this proportion makes it into your notes. So let's take a look at one more example with our angle bisector theorem. This is asking us to find the lengths of BD and DC. And if you look carefully, it does tell us that angle BAD and angle CAD, so these two angles right here, are congruent. So I can set up my proportion DC over BD is equal to AC over AB. And when I substitute in their actual lengths, I get x plus 1 over x plus 2 equals 5.6 over 7. When I do my cross products, I'm multiplying 7 by all of x plus 1, and I'm multiplying 5.6 by all of x plus 2, so I'm going to have to do some distribution. I get 7x plus 7 equals 5.6x plus 11.2 when I get all my distribution done. When I solve an equation with variables on both sides, I need to subtract one of those variables from both sides. So I'm going to subtract both sides by 5.6x. If I subtract 5.6x from 7x, I get 1.4x. And then, of course, I still have the plus 7 and the 11.2. Then I'm going to subtract 7 from both sides, and I get 1.4x equals 4.2. And finally, I'm going to divide by 1.4, and I find that x equals 3. Here's the important part. Is that what the question asked for? Was I just supposed to find x? Of course not. I was supposed to find the lengths of BD and DC. So if I look at BD, BD is x plus 2, and if x is 3, that's 3 plus 2. The length of BD is 5 units. And if I look at DC, that's x plus 1, and if x is 3, that's 3 plus 1. The length of DC is 4 units. So that's what I need to put as my final answer. All right, I think that's enough for today. Make sure to bring me any questions that you have. We'll get our assignment done in class. I hope your day is fantastic, and I'll see you next time.